This is Hien Luu, working at DoorDash and leading the machine learning platform team. Been here about 2 years. I like my coffee with cream and no sugar.
Yeah, I'm Kunal. I've been at the model, so I've been leading the model development platform team at DoorDash for a few months now, and I've been at DoorDash for about 2 years. And yeah, I like my coffee in all kinds of medium blends, usually black, sometimes with a little bit of light cream and light sugar.
Hey, I'm Swaroop. I'm an engineer in the machine learning platform team. I usually take latte and stevia.
Hey, I'm Cornell. I'm also an engineer in the machine learning platform team. I like the coffee black with a little bit of almond milk as an extra.
Hi, my name is Arbaz. I joined the machine learning platform team about 2 years back. I lead the model serving platform, and I'm the only one who doesn't drink coffee here. But when I do, I drink it cold. So, yeah.
Super excited to have not one, not two, but basically the whole team. It's like Christmas came early for me. I get to talk to DoorDash. I'm here with Skylar, who is the trusty co-host of this MLOps community podcast, our coffee sessions. And we've got so much to break into. I have seen, and I think like many others who are probably listening to this, they've read the DoorDash posts. We've seen you guys talking in various conferences. You give so much information. You're so transparent about what you're doing with the machine learning platform at DoorDash. I know that when it comes to DoorDash's business, you kind of have to be leveraging machine learning, and it is such a huge piece of the business that it is critical. And so maybe we should just start with the background. And Hien, maybe I can go to you first on what exactly are you doing for the platform? How does it look? Can you give us the overview, like that 10,000 foot overview, and then we can dig into some of the specifics?
Absolutely, yeah. Like you mentioned, machine learning plays a big part at DoorDash in terms of what we do on a daily basis. It powers many of the core infrastructures that help delivering food and grocery to our customers. So the kinds of use cases is diverse, and that's one of the things I love working at DoorDash, including our core infrastructure is about logistics, right? Delivering, taking orders and then assigning orders to dashers and then help them deliver those orders. To standard use cases like search recommendations, also ads and promotions, to forecasting, for example. That's another big part of how we use ML at DoorDash. And other kinds of use cases around fraud. Obviously, we have users on our platform, so that's a big part of that as machine learning as well. Yeah, I would love to hear others to jump in and share their thoughts as well on this question.
I think ETA is another big use case.
Yes. Yep.
The number that you see, like how many minutes away if you order from this restaurant, that takes a lot of machine learning to get it right.
Absolutely.
So these are fun challenges for sure. And what exactly does the platform look like? What are the tools that you all chose to use? What's homegrown? What is stuff that you've got from open source? And did you pay for anything? And maybe a little bit of the design decisions because I mean, it's funny enough, while I was preparing for this, I saw the YC interview from the founders of DoorDash. And I think it was like YC 2013 or 2012 batch. And so machine learning wasn't that predominant back in those days, but you all have been doing machine learning for a long time. Does that play into the choices that you've made? So, yeah, Hien, what does it look like?
Yeah, I'll start with the high level, and then each of the leads can talk a little more specifically on each of the areas of the platform. We can go from feature engineering to model training to model serving and forecasting and so on. At our highest level, the machine learning platform that we aspire to build is like a world-class platform that covers end to end in terms of solving the applying machine learning with DoorDash, and at scale as well. That's another very interesting challenge that we have to deal with. It spans from start from the beginning, right? How do you do feature engineering all the way to model serving and model observability and so on. In terms of like how we think about building it, kind of cover a little bit on the blog that I share. Some of the principles that we use, like dream big, start small, 1% better, and customer obsessions. All platform consists of a mixed bag of commercial vendor solutions, open source, as well as homegrown solutions. And maybe Kunal can jump in and maybe talk a little bit about how we do feature engineering.
Yeah, thanks, Hien. So, yeah, this question was a big loaded one, so I'll try not to go too deep into the weeds just yet. But yeah, the journey of an ML or a data scientist starts with the feature engineering process. And so we've spent a lot of time trying to improve the ecosystem around how quickly they can build and deploy features, both for offline and online access. And so you go all the way from the users trying to experiment with features within their own notebooks, deploy those to production. And again, that kind of goes into warehousing, which again, we have a mix of both open source and enterprise solutions that help the warehousing the process. And then we go down to the compute, which is then what does it take for a data scientist to build those features quickly and using a standard paved path that lets them, stop thinking about what's the way to make this really fast, but rather think about what's the business logic that goes into my features. And then once we get through those process, then we kind of go towards the production access. Like it's not enough to just build features. You now want to start thinking about how to serve them. And again, we've kind of surveyed a few open source solutions over time. And I think we have Arbaz here who can touch upon it, but we have a really scalable feature store that is capable of serving a really large volume of features in production, going through somewhere around a few billion updates daily. I think more recently it was 50 billion updates a day. But again, we began with Redis or Elastic Cache, and then we've been expanding that over time. And that kind of goes into serving features. And then lastly, one more piece I'll touch upon is that once you have the features ready, you have to start trying to think about building the data sets for training and then actually doing the training. And once we get into that process, like that's where we work with the data scientists towards how to build standardized models that can be served in production. And yeah, with that, I'll hand it out to our boss for the serving side.
Yeah, thanks, Kunal. So yeah, the serving side was actually one of the very first components that we built out in the machine learning platform. It was the face of our production machine learning. It required us to do a large amount of computations in a small amount of time and do it reliably. So you're talking about like 4 nines of latency, 4 nines of availability. The latency being somewhere in the order of 1 to less than 1 milliseconds per prediction, and like 100 billion predictions a day. That's the kind of scale. And we had to do it all within the confines or the constraints of the microservice architecture at DoorDash, because that's when all of the infrastructure level best practices, optimizations come for free. We wanted to stay within that. So that was the challenge we had been dealing with. So, because of this, everything was built in-house for the serving part, the whole microservice and its other integrations. The only vendor that we might have used at that time was for streaming the responses back to Snowflake or a data warehouse for real-time analysis of the predictions. Which also, because of scale, now we have switched to in-house Kafka solution. Yeah, and then the feature store was a big part of us scaling up. That used to be a bottleneck in our performance latency. It still is. I think 80% of our latency comes from talking to feature store. So that has been our prime area of focus. There have been multiple iterations, as Kunal mentioned. We did starting from Elastic Cache, moving to CockroachDB, and then doing other kind of research as to what are the formats that will work best for us. Yeah, and I think it apart from feature engineering, the other part that it integrates with is the model repository, which is populated by our model development team. So Cornell here can talk about our model development framework.
Yeah, so once we have the features, we want to be able to train the models, and we adopted a lot of MLOps principles there. So we want to make sure our code is reproducible and we can go back to the original source code to see how the model was trained, make easy adjustments. So we adopted this principle of committing code to GitHub repository, Git repository for later use, and code gets reviewed. So we have high confidence in what our models are doing. We've also ventured into retraining models periodically. That's going to help the models stay fresh as well. And the other thing I would like to mention is once we have launched the models in production, we want to be able to understand how they are doing. And so we've invested a lot into model interpretability and model monitoring as well, which are really important for like our business. We want to make sure models are continuously making predictions that are high quality. And so we like measure typical metrics, AUC, log loss, and so on. And the one thing that ties all of this together is we have the vision for an internal web page. We call it ML Portal that allows us to launch models, look at the model repo, the feature repo, look at the model interpretability. And so, yeah, so our vision is to democratize ML at DoorDash and be able to provide this as a service to anyone just by navigating through this web UI. And so maybe Swaroop can talk about more about some of the other applications as well.
Yeah, I can talk about forecasting and a bit of ML portal as well, which uh, the engineers I work with, we focus on. So for forecasting, uh, we are using it from business planning to internal use cases like variance reduction in our experiments, product experiments. So ideally would like to have product experiments run quickly, and forecasting helps speed that up. Um, so forecasting is a slightly different beast. It's offline training and offline predictions. And this is the kind of use case where we are building on top of the training and serving platforms that our boss Cornell and Kunal and team are building. So in this case, we use Python, Daxter for orchestration, Databricks clusters, Snowflake, and we use Retool for building internal admin UIs. And for the ML portal, as Cornell mentioned, we are trying to build it as the internal homepage for data scientists. Like anything you need to get done on the ML portal, you jump onto ML portal. Um, think of two things: observability. So, what's happening with my model in production? What are happening with the features? Can I test out a new model that I just created? And even deploying models goes through a self-serve workflow that our Baz and team built. So these are the kinds of things that we're looking into as well.
Does that include things like experimentation? I think like one piece that felt like an open loop in my head was like how are we experimenting and testing new models? Can you maybe speak to that a little bit?
Yeah, that's a great question, and actually an active project that we are taking on. So Arbas can add to this as well. But we have an internal experimentation platform called Curie, and we are currently working on integrating the experimentation platform into our ML platform so that data scientists can experiment on new models without having to approach the product engineering. Arbaz, anything you want to add to that?
No, yeah, I think the experimentation was all left up to the data scientists. As Swaroop mentioned, product engineering had to work with all these data scientists, and that reduced the velocity of iteration on models. People had to, sometimes set up all the experimentation framework from scratch. I mean, there was an application available to see, visualize their experiments, see the results, and all of that, but some work had to be done to set it up. So what we are doing right now is to provide that out of the box within the serving layer. So people can just use the existing application that we have for experimentation. And there's a lot of blog posts already on Curie, which is our experimentation platform, and how it's able to run a large scale of experiments throughout the day. So all of this is being tightly coupled with a serving layer, so that all data scientists have to do to set up experimentation is to just click some button, set up the UI, and that's how they get better at experimentation.
That's super cool. Thanks for sharing. I think this gave us like a really good overview into all the different steps and parts. One of the things I'm curious about, in case folks didn't realize, Hien and I work together at LinkedIn a little bit. So kind of just want to roll the clock back and just, I think there was a lot of, definitely a lot of mistakes that we made in like building a machine learning platform, a lot of lessons learned, a lot of things maybe we did right. Just curious about like, was there anything you were able to take away from the experiences we had in building ML platforms at LinkedIn and apply here at DoorDash? Anything we learned like, oh, absolutely, that doesn't work, we shouldn't do that, and it kind of paid off at DoorDash? Love to hear about how experiences are transferring.
I think my experience at the ML Infra at LinkedIn is, it has gone through that evolutions of, there was no solutions out there. A lot of us, had to come up with, ideas in-house. There's nothing to model after back then, right? I think for us, we started our journey about 2.5 years ago, and there's quite a bit of resources out there that best practices that we can leverage. I would say the biggest thing is that I see is not so much about technology. It's how do we really engage with our data scientist community to help shaping the direction to the platform. I didn't feel like that when I was LinkedIn, and that's one thing that I really trying to do very differently when I got here at DoorDash is how to really engage our customers as part of a journey of building the platform. Not just us building it, we're building it along with them.
Yeah, I think that's a great answer, and would love to dive deeper into it because I think it's such like a beautiful approach to like you really need to engage your customers, and I definitely concur with that assessment that like I don't think that we got that quite right at LinkedIn, especially early on, and definitely there's a lot of hindsight is 2020, after like after we learned the lessons, like oh, okay, but very curious, and I'm sure listeners would love to know, especially as people building their own ML platforms, like how do you like effectively engage with your customers? How do you like make sure that you kind of bring data scientists in and essentially build the platform with them? So what are some ways that you see that playing out and how you maybe make that happen?
Yeah, I can start at high level, and then some of the leads can feel free to jump in as well, especially the folks. Most of these folks, by the way, have been with the platform since the early days, so I'm sure they have their own view and perspective as well. Yeah.
The veteran.
So how do we do that at DoorDash? I think in the early day, what we established was we call something called Machine Learning Council, which consists of representatives from the data scientist community and a couple of the leaders from the search team that using ML heavily. And we sit down together and align on the directions. And we have constant communication in terms of like bi-weekly, we're sharing updates of what we're doing, and they can bring up like challenges that they're facing. If we do some kind of like vendor evaluation, it's transparent to everybody and they know what we're looking at, and they also request us to look at some of the vendor solutions. So I think that one piece really helped aligning everybody on the same page in terms of what we're doing. There's no we versus them kind of mentality. It's all of us, right? How do we make this successful at DoorDash as a group? And then continue on that is about we do planning together. Like quarterly, we ask them what they need, and then we go through that prioritization process, and we attend their workshops. They provide workshops on how to review the models. We attend those, as well as giving our presentation to the data science community of what's being built, what's new, what are new features. So this constant back and forth communication and involvement. And the last thing I'll mention is we invite those data scientist folks and leaders to come in our team and have a lunch, have a chat over lunch, just to get to know them, especially some of the new folks. I'll pause here, and if any leads want to jump in and add your 2 cents, feel free.
I was going to add that, like, apart from everything that he mentioned, like a few things that also kind of help us expand the platform is that based on some other experiences I've had with ML platforms before, we don't tend to build things because they're cool. We as folks that have played around with ML platforms for a while might have an idea where some value lies for our customers. But we kind of, approach the conversations with them in all the councils that he mentioned to kind of engage with them and see if this is of immediate value to them. And that's typically not of immediate value to many of the verticals, right? So we want to find a few verticals where this aligns and then use that as an impetus to design right, because over designing is a common problem that platforms go through, where you might end up building something that isn't particularly useful. And so we try to avoid that as well by building small things first and see if that actually solves a problem in a big way, and then take that further along the way. And that kind of helps us not overexpend resources in the white. And that's where, as Arbaz mentioned, the inference service skyrocketed first, because that's where the biggest problems were. And we use that to identify newer ways and slowly add pieces to our platform.
Yeah, to add to that nuance, I think one thing that we've been doing successfully is we have strategy sessions within our team, as well as combine that with the customer wish list process. So what happens is we kind of come up with where do we want to be a year from now, and have some consensus within the team. But that doesn't mean we just go straight away start shipping it. We kind of look at the requests from our customers every quarter, that Hien sends out this spreadsheet, and all the DSML teams kind of fill in what they think are things they need help with next quarter, or things that are blocking them this quarter. And then we kind of, mash them together and come up with what are the parts that we want to build that is impactful and useful for our customers now, but is also on the line of where we want to be a year from now.
Yeah, right. I think so. The other a couple of components as well that I'd like to add. So Hien talked about like raising awareness amongst our customers, and Kunal talked about how do we choose a sweet spot of flexibility, like offering just enough kind of customizations, but not too much to make the platform look all over the place. I think, and Swaroop was talking about hand in hand collaboration with the leads of data scientists. The other thing that comes out in my mind is the velocity at which the data scientists can move. So how quickly can they onboard a new model? How quickly can they write a new feature pipeline? How quickly can they experiment on their models? So that is like a prime value proposition that a machine learning platform can offer. It's like if there are lot of friction along the way, then it gives birth to the scenario where there can be multiple machine learning platforms in the same company. And that has been the case in some of my previous experiences, where people have just built something of their own because they weren't able to like make peace with what was offered. And so yeah, the value that the machine learning platform provides and the velocity at which it provides that value, that comes to it.
One important aspect is how can we get our customers, the data scientists, onboarded to new launches. So it's one thing that we launch something really cool and useful. It's another thing that people actually use it. So a lot of times we have to work together with our customers to make sure they get onboarded. A lot of new features require migrations, and so we have to come up with a good migration strategy. Is it something where we distribute the migration? Is it something that we do centrally, or is it something that we do in a hybrid way? That's typically a challenge for these new launches as well.
This is so good. So, first of all, I love Kunal. I think it's hilarious that you keep referring to Hien as your boss. It's like, don't forget, guys, the boss is on the call, so make sure we say everything perfectly. We gotta button it up, make it all nice and sound sweet. So, just out of curiosity, though, while I'm thinking about everything that y'all are doing, what are the teams like? Because you're all the leads on these different projects and initiatives. How many people do you guys have working with you for, and like, what does the platform team look like as in terms of size?
Yeah, we started out small and then it been evolved, and the team size has increased over time. So we have organized ourselves into 3 sub teams. I call them model development and platform team, which is responsible for like feature engineering and model training, and the right path of the feature store as well. And then we have the model serving team, which is responsible for the online predictions, offline predictions, and the read path of the feature store. And then the third team we call the machine learning applications, which is responsible for the forecast platform that's what we mentioned, as well as other pieces of infrastructure that are on top of the pillars that we build. For example, the ML portal, which is a web-based application that's what we've mentioned, that essentially provide a unified experience for our data scientists, but it leverages all the underlying infrastructure that the other teams provide.
I love that, and I think it's a nice little nuance there that the read and write team for the feature store are different, or it's not combined to the same team. That's an interesting choice. And
They do work together because at the end
yeah.
of the day, it's a one single feature store, but each these size have their own requirements and needs. But they do need to work together for the whole feature store to work and scale.
Yeah, completely. And I want to dig into that internal tool that y'all have got in a minute, that dashboard that helps you track and have better visuals into what is going on. But it's also probably, I guess, by way of that, we can talk a little bit about the metrics that you use for what you're looking at as far as how you know data scientists are successful. There was mention of velocity and the ability to get something out, like create a new feature or deploy a model. What other metrics are you all looking at?
I will let Cornell talk about this. He's our metrics guy or engineer on the team
The numbers guy?
that helped us tracking and everything. So Cornell, you wanna share?
Yeah. So on a high level, we care about how our platform is doing. So we track things like number of models, the availability of our online services, the scale of the features that we create and upload, um, things like how much people use our internal ML portal, um, and just general health of the system as well as scalability. So what is our cost per prediction or cost per delivery, things like that. Um, in terms of model metrics, we uh, typically look at number of predictions, the availability, so like the latency of those predictions, and then we look at qualitative metrics as well as how that model is doing. We look at a lot of statistical information of the features, so like the inputs to the models as well as the outputs, which is the prediction. So we look at percentiles, average, number of zeros, things of that nature.
There's another qualitative aspect, which is the customer survey. Cornell, do you want to talk about that as well?
Yeah, so typically I think once every 6 months we send out a survey and to see how our platform is doing in the eyes of our customers. So we ask about like how satisfied are you with this service or that service, a component of the platform, and so that's a really good opportunity to reach out to our customers and understand if there's anything that's if there's any mismatch in what their expectations are. We get a lot of interesting text feedback as well in that survey, so we engage with our customers this way as well.
Yeah, incredible. So now, I didn't really have a specific question on this internal tool, the metrics, but I just want to know more about it because it seems like something that, if I understand correctly, you have a visual into the whole life cycle.
I think from what I gathered, the question seems to be around, is the internal tool just making sure that the metrics are correct, or is it doing something more as well, right?
Yeah, at a high level, we are trying to simplify things, right? It's basically our North Star of velocity. So imagine the case of our data scientists have to look up the workflow orchestration status and look up the metrics dashboard. Now, all of these are in separate places. So for our data scientists, we are saying, oh, you want to look at this information, go to this URL. If you want to look up this information, go to this URL. And then it's left to them to interpret what they're looking at. So that was the situation before. The situation that we're trying to get to is, you want to know about your model, go to your model homepage, and all the basic information you need is there, right? So for example, Kunal and team have been working on lineage. So like what are, for a given feature, like what is the upstream data, where is that located? Now the basic information is in our model homepage, but if they want to dive more, they have the links to jump to the full tool that the sister teams are providing. So that is one way we're trying to simplify things for our data scientists. So if there is an alert, then we can show it in that homepage. If there is things that we know are problematic, then we can highlight those, and not always having to leave it to the data scientist to interpret what they're looking at. So that's kind of one way that we are trying to make this improve the velocity for data scientists, and the other way are workflows. Arbaz, can you talk about like deploying models? What was the before and after?
Right, right. Yeah. So I think like apart from seeing the current status, we also started to invest on building these workflows or triggering these workflows from within this tool. So things like being able to train a model, being able to deploy a model. So it has these dialog boxes that have all these various options that would otherwise require creating separate pull requests to our repositories. Now we data scientists can do it all within the UI, just by following these workflows, which has helped tremendously, and it has actually been the matter of preference for the data scientists. We have seen that around 70% of data scientists prefer working with the UIs versus the 30% who are actually power users who want to like play with the JSONs and the low level formats.
That's awesome.
Yeah.
Yeah. Another way the ML portal has been helpful is the number of support questions that we get in our Slack channel has reduced as well. So that's another way we kind of iterate on our ML portal. That if there is a question that keeps coming up, can we answer this in a so that future questions don't pop up on the same lines.
And like I just want to add one more piece of context here. I think one thing that's changed in the life cycle of the platform is that as we've grown and our data scientist community has grown, we've added a lot of tooling for ourselves, right? Like, and we as a platform actually sit within a broader data organization, which has a lot of tools of its own. And it's a lot of burden to think of data scientists to onboard each new thing we build at the DoorDash scale. Like you add Grafana to the mix, you add Chronosphere to the mix. As we add each tooling for ourselves, it's not accessible to our data scientists in the same way. And so and it's still a continuing vision, but the vision is to have this central place collate all information that they can use now or in the future without us expecting them to onboard to it. It makes our life easier as well when we think of bringing that information to them.
Yeah, self-serve is huge for our platform. We want to make sure every step of the way data scientists can launch models and everything. We don't want to have to hold their hands, and we want to make sure our team scales well with the rest of the organization.
Awesome. And you may have mentioned this very explicitly, but it sounds like you're using retools. Are you using that to build these kinds of like this app essentially for users?
So the way we use retool is more of a 0 to 1 kind of a tool. So something that needs to be prototype or something needs to be built that does not have a wide audience. We kind of use retool to build our first cut and start testing it with users. ML portal specifically is a regular Python Flask React application. But for forecasting, we are building the UIs on top of retool.
Oh, it's interesting. Cool. Two of the other tools I think I heard you mention that you use is Databricks and Snowflake. Is that correct? So it's interesting to hear that, mostly because like in a lot of the data space, there's always a lot of head-to-head of Snowflake versus Databricks. So it's very interesting to hear that. Like, it's interesting to hear that. Hey, we're using both. And I think like there's a lot of people in the community that like when they're thinking, especially of like, hey, we need a sort of data warehouse of some sort, they're thinking it's Snowflake versus Databricks. And so would love to just hear about how do you use these tools, particularly together, to kind of like educate the community that like, hey, it's not an either or.
Yeah, I can take a stab and then maybe Kunal can jump in too. DoorDash has started with Snowflake as the data warehouse in the early days and continue to use that. And then they need a way to essentially how to run computations on top of Snowflake. And that's when Databricks was brought in and to help with some of the early data scientist work. And it has its values in terms of providing, the notebook service, the ability to launch compute at at a click of a button. So those are the things that we really like about it, and we don't have to spend a lot of engineering effort in building those infrastructures. So we have the way we use Databricks has evolved a bit over the last couple of years. We use their API to launch some of the training jobs, for example, and other feature engineering compute jobs as well. And data scientists continue to use the notebook service for their model explorations. So that's where we at, and that's how our journey was started of combining those two together. However, we're going to move forward with using Data Lake move forward as we doing feature engineering at scale. We need to go through we need to leverage Data Lake instead of Snowflake for that purpose. Anything you want to add, Kunal?
Yeah, I'll answer this in two parts. I think the journey is interesting because it's easy to think of these technologies as synonymous, but there is two parts, which is the compute and the data, right? And so when we began with storage and warehousing, Snowflake was and still is one of our dominant data stores. But compute doesn't necessarily need to follow the same suite. And that's where Databricks has helped our data scientists scale the part of bringing data out and connecting to their models in one plane of execution. And so for us, when we began our journey, it was still trying to collate these two worlds where we want to switch our data scientists towards a faster storage layer once in a while, depending on the use case when it comes to arrays, embeddings, and so on. And that's kind of also where we stepped into thinking in more declarative senses, where like if we design a framework that can be agnostic for which storage we want to evolve into and which compute we want to evolve into, the data scientist experiences can stay the same. And so that's kind of where we've been heading into as a platform, which is to try to change the conversation for the data scientists from I want to use Databricks or I want to use Snowflake to I want to do X for my models or for my features, and I want to store this particular thing faster or at this much scale. And if we move to those questions, we can possibly help them make those choices better as we evolve our platforms too. So those are kind of the two sides of our platform's journey.
Awesome. One of the questions, since Dimitrios' mic is acting up, that he pinged me that he was curious about, is kind of rolling it back a little bit, talking about the UIs that you have. And it sounds like most users are using that, but you have some power users. And Dimitrios was really curious about, like, what do you do to support power users, and how do you go about thinking about that?
Yeah, I think the power users are like folks who just want to interact with our the raw data, the GitHub repositories, and the reason why they prefer doing that is because it is more like what you see is what you get. There's like there's no magic happening behind a UI workflow, and there's like some more integration that GitHub provides, which are UI does not. Things like version control and history and all of that. These are the kind of things that if theoretically we were able to build it into our UI, then it would satisfy all their needs. But yeah, it's just something that you have to cope up with. That there are some people who would like to get into the weeds rather than just like work with the top level abstractions. And these are the people really who drive the next generation of features in the platform. They are the ones who come up with these wish list items that, hey, how about customizing this particular feature to be able to also do this? And they really drive what a typical customer would look like in the next couple of quarters. So yeah, Hien mentioned about the Machine Learning Council. We have a tech steering group that involves a lot of these people, which we interact with on like a set cadence and try to understand what are their current pain points, what are their current point of friction, and then take it from there.
Yeah, another example is like Kunal had added the ability for folks to contribute their own modules to the feature engineering. So people can contribute their Python code that can be reused and shared across the rest of the data scientists as well. So if they have specific needs, then they can contribute to the that module.
Awesome. I think we have a few minutes left, and so one of the things I'd love to just close us out with, obviously, there's you have like a lot of rich experience in this space, both from building the platform at DoorDash, but also it sounds like most of you from previous experiences and whatnot. And there's definitely an eager community of people really trying to either break into the space, they're starting to build their platforms and whatnot. And so, like, if you had to give or impart one piece of advice or wisdom from your experiences of building machine learning platforms, what would it be? I'd love to hear from each of you, your take on that.
I can go first. I would say the biggest learning for me is how do you balance velocity and reliability. Uh, these are opposing forces, but as I have it in my background, at DoorDash, we try to think of and not or. So, how do you do both velocity and reliability is something that you should start thinking from day one.
Yeah, one thing that I have learned is that we always think of machine learning platform as a suite of offerings and try to build towards that suite. Uh, but that flexibility is what brings the long tail into the machine learning platform and not disintegrate it into multiple different pieces. So like offering that little bit of flexibility is something that can bring a lot more inclusiveness into the platform.
Yeah. One of my key takeaways is to like start small and dream big and iterate on the
Cornell, you want to go
implementation
next?
and adopt as the needs change. And the other, uh, and also be able to scale as the customers grow. That has been one of the other learnings.
Yeah, it's kind of like a mixture of what's been said. I think we all share similar learnings. I think for me, it's like one takeaway has been that if you start with
Kunal?
a generalist platform straight out of the bat, you're going to actually struggle a lot with adoption. Uh, like we've done this in the past where like a lot of features come in because they all sound great to have on the platform, but that solves not a single problem end to end. So my learning is actually take a single problem and take it to the very extreme of the solutions you can. And that's one way to get the customer all dependent on the platform for their primary use cases. And that's when you start to think of expanding how to take them further. And I think that's really helped us scale DoorDash's platform, ML platform, quite well over time without losing customer faith, I guess. Nice.
Yeah, plus one to everything everyone that was saying. Two things I want to share. One is at the high level, it's really about organizational alignment with your customers. Because I hear companies that have challenges of building ML platform because that's there was no alignment between the ML platform team and the rest of the organization. That's probably one of the biggest things to make sure that everybody's aligned on the same page. Two is besides the dream big start small, is about what we call 1% better every day. It's about how do you consistently iterate on what you built and make it better and better every month or quarter. Because you're probably not going to get it right in the first try, but you got to make sure to stay with it and improve on it. And that's, I believe, has been help us quite a bit because we focus on that.
So good. So amazing. Hopefully my mic is working again and everything is all right. If it's not, Skylar will tell me. Fellas, this was awesome. I cannot thank you enough. I was joking before we hit record that this is the most expensive call I've ever been on. I still think, as far as knowledge being dropped, I appreciate you all taking the time to come and talk to us. I mean, it's so cool to hear you all. You've been in the trenches for the last, I don't know, like, dare I say, a decade building platforms, and maybe not at DoorDash, but before that, you were doing it, and the wisdom shines through. So I thank you so much. There's so many great quotes that I am going to take away from this, and that's it for now. We'll see y'all later. Hopefully everyone enjoys it. If they want to get a hold of you, We'll leave everyone's contact details in the description to reach out to them on LinkedIn or on the MLOps community. Are you guys hiring by chance in case there's some ambitious people out there that want to join the team?
We are still hiring, so yes, do let us know.
There we go. There we go. Cool. I love hearing that. Thank you again. Appreciate it so much.
Thank you. It's been fun.